I'm Professor Penelope Allison from the School of Archaeology and Ancient History at the University of Leicester. And I'm particularly interested in how we can use Roman pottery to understand eating and drinking practices in different kinds of Roman households. We've got some sort of a generic idea of what a Roman household dinner party was like, but what we're finding in archaeological sites is a massive data, a massive ceramic remains, which actually pertains to everyday eating practices in different parts of the Roman world. And I was very interested in whether we can sort of start to use this material to trace how people in different parts of a huge, complex, culturally complex world might be using this material in different ways for different social practices. We had about 50 participants who took part in 2 different workshops: academics, ceramic specialists, other professional archaeologists, mathematicians, computer scientists, and also people specialising in digital humanities. And one of the main problems that came out from all these papers was that we really didn't have enough comprehensively and consistently recorded data to answer the sorts of questions that we wanted to do, particularly to answer questions about intersite analyses. Professor Jeremy Leavesley from the Department of Mathematics, School of Mathematics at the University of Leicester took part in the first workshop. I had several discussions with him and also with other members of the mathematics school, particularly Professor Ivan Tyukin, about ways that we could sort of use mathematical approaches, not necessarily just for the analysis, but also for this kind of getting comprehensive data.
We started with looking at the practices and standards of consistently recording pottery. At the moment there is a standard and very well established practice of recording by comparing pottery and elements of pieces of pottery to a catalogue. And the catalogue contains a variety of geometric shapes and patterns, and then those are then linked to a particular piece. Our aim was to look at massive volumes of different pieces, and of course that's unaffordable and unsustainable.
As I say, we call them whole pots, but when we talk to the mathematicians, they've got holes in them, so they say these aren't whole pots. No, they're not whole pots, but they are whole pots to archaeologists.
We first ask ourselves, can we in principle identify a limited range of pottery pieces? In this experiment we didn't use information about the texture, we didn't use much information about fine geometry of the pieces, because the machine that we used to detect those objects and identify them was only looking at gradients, the so-called histograms of oriented gradients, so which are essentially just enable you to draw a contour around an object. So there is no information about the color, and there was no information about the texture that is important. And that brought us to the idea of why don't we scale up and do a much larger experiment and build a system that would be capable of identifying different and finer details.
From all these partners we were able to get large consistent bodies of pottery, tablewares or finewares, and of course the one that's most ubiquitous across the Roman world is Roman terra sigillata, or what's locally called Samian, so that hopefully we will have something in the range of about 200,000 sherds recorded. We've done some recording in the Museum of London, and we've done a couple of weeks in the Museum of London Archaeology, and things seem to be going quite well with that recording.
Yes.
I'd like to introduce Dan Van Helden, who is the postdoctoral research associate on the ArchiScan project. He is the archaeology postdoc on it, and so he's very much responsible for designing and working with the mathematicians in the project to try and set up a scanning program for ArchiScan.
Yes, so I describe my role often as the archaeologist translator. I talk to the archaeologist in the project, and I also talk to the mathematicians, and then I hope to minimize any miscommunication and optimize communication between these two groups. I'm largely responsible for designing the scanning process so that we get the photos that we need as efficiently as possible and as systematically as possible.
It's a great pleasure to introduce Nick Cooper, who's the Post-Excavation Manager for the University of Leicester Archaeological Service. He's one of our important partners for the ArchiScan project, as we're using a lot of ULAS data for our scanning project. I think, Nick, I just have to try and remember how you got involved in the first place.
Well, we offered a paper to the Big Data on Roman Table conference, the first workshop. We talked about some of the results of analysis that we'd done on tablewares from excavations in Rome and Leicester, and from that we then started to explore the idea of doing automated pottery recording, and from there, you know, we've been exploring the idea of looking at really large groups of material and seeing how we could develop a technique to record material on a consistent and much larger scale.
So that do you think is your main interest in the project, getting more people involved in the recording?
Yes, yeah, well, definitely. There's the two levels really. There's the broadening the access to knowledge, if you like. If you think there's only about 100 people at the moment in this country who know how to record Roman pottery, and a lot of those are getting older and older as time goes on. So there's a potential skills loss across pottery and finds in archaeology, and so we badly need to be able to broaden the knowledge base. You know, if we can create an app that can allow people to record material and get it identified using this system, then we've got a great way of generating more data.
And where do you think that puts you in your role? Do you think that's going to make your role more interesting or harder?
Or superfluous, you mean?
Yeah.
No, I'm sure Roman pottery specialists around the country are quaking probably with fear at the future of this, of where this is going, this system. But no, you will still require the expertise of people in terms of the sort of the interpretation of assemblages. That's never going to go away, but it may enable us to record things more efficiently.
Comprehensively.
And comprehensively, yeah.
Artificial intelligence is the development of computer systems that help us to perform tasks that require some human intelligence. Machine learning is a sub-branch of artificial intelligence. In that case, we don't give any instructions of how the computer has to perform its task, but we rely on it to create its own features, and out of those features it will learn how to perform its task.
So what we give the computer or the AI is a set of images and a set of conclusions that we want it to draw, and then it teaches itself how to reach those conclusions.
Yeah.
We don't know what the machine does there, do we?
Yeah. No. There is a lot of work in that direction, but we still think of, or still I only think of those computers as mostly a black box.
Because when we identify pottery, we don't go by a set of rules. What we need to do is just get a lot of images where we know what it is, feed those to the machine and tell it, this is the conclusion you need to draw, and then basically hope that it, cross our fingers and hope that it does what we want it to do.
That's correct, that's the aim of it.
One of the major parts of the project is to make use of the advantages of artificial intelligence and machine learning to advance knowledge in archaeology. And I also mentioned this sustainability problem, like what happens once everything is done and once we collect everything and build the system. So we will use in our project a novel technology for learning on the fly. So like, let's say when we build a system and an expert says, look, actually the output, it's not what I think it should be. So the system will be equipped with the capability to learn from that feedback instantaneously without destroying its existing skills. And we can give a priori estimates of the probability of a damage that may result in such a learning, and then whoever is moderating the system would be able to make a decision whether to actually accept this correction or not. And again, the technology is such that even by mistake this correction is accepted, it can be undone. The second problem, which became also important and obvious, is the problem of robustness and resilience, and how do you trust that actually whatever the artificial intelligence system tells you is exactly is the case. And this is important in particular in the modern days when the issue of trust, safety, robustness and resilience in AI are becoming subject of public debate and focus. In our project, that was also an inherent part of it, and the majority of our technical task will be focused on ensuring this robustness.
So then I'd like to introduce Fiona Seeley, who is Head of Finds and Conservation at the Museum of London Archaeology, who is one of the partners on the Big Data and the Roman Table network.
Hi, thank you, Poon. Yes, my title is Head of Finds and Conservation. However, with this project, I'm really using my specialism, which is Roman pottery, which I've been doing in London for almost 25 years. The idea had come out about scanning ceramics, using mobile phones to kind of recognise pottery types and typologies, because one of the issues is that takes, as a ceramicist I know, it takes a lot of time, and this was one way of using technology to identify forms. So we're looking at tablewares, and I know Pim was particularly interested in imported wares. So I suggested that if they needed to collect some of the data for this application, they could look at the Museum of London's ceramic and glass archive, and that's just how it's really started. For us at MOLA, this is particularly exciting because it's not the kind of thing we get to do every day. It was research, it was kind of a bit of a leap into the unknown, so we're really quite excited about being involved.
So we're trying to get as many sherds done as possible. Currently we're taking about 5 minutes to process a single sherd, and we have done over 3,000 sherds already in the past week and a half. This is why we need so many volunteers, because the more sherds that we can process, the more sherds that we can photograph, the more images we have, and the better we can train the artificial intelligence network.
I'm Barbara, and I'm a third-year student. I'm studying history and archaeology. I'm particularly interested in classic archaeology. It's a project about Roman pottery, so we have like the option to touch and see like different fragments with like decoration.
I'm Imogen. I'm doing my final year BA History and Archaeology. I decided to volunteer for this because I'm deciding on what masters to do, and I'm quite interested in the post-excavation and curating side of things, and I thought this would be an excellent chance to see if this is where I want to head. I've never been good at maths, so seeing like maths in practice and how it's building together is quite fascinating.
I'm Robert Hunter. I'm in my final year of my Masters at Birkbeck Archaeological Practice. I'm here because I really am interested in digitalisation of the archaeological record, and yeah, this is fascinating.
I'm Anne Russell. I'm doing a Masters in Archaeological Practice, but I'm really interested in Roman pottery, and also I'm interested in the technological side of the project, because this is a new way of tackling sort of, if you like, archiving and researching pottery.
I'm Paul. I'm a final year archaeology student. For my master's, I'm applying for archaeological science, and I'm interested in computational archaeology, artifact scanning, GIS, that sort of stuff, which is why I'm doing this, because this is very much that category.
My name is Ryan. I'm a construction manager in real life, but always had an interest in archaeology, and basically I just got a chance to get my hands on some Roman pottery, which is something which I've always wanted to do.
Casey, I am an undergraduate student studying archaeology and history, and this is actually the job I want to do when I finish uni, so I thought it was a good work experience.
I'm Nicola Glanville. I'm studying classical archaeology, really interested in Roman pottery, and this is an ideal project to be involved with from my point of view, and so exciting to be part of it.
And have you got any experience of big data and digital methods?
I'm afraid not. No, that's where I'm lacking. But I'm very happy looking at all this pottery and helping to photograph it so that the machine will be able to identify it, which I think will release a lot of time for senior archaeologists to be able to think about theory.
Hi, I'm Alman. I'm an archaeology student. I'm an undergraduate student. Studying Roman pottery like this is an amazing experience. It's really unique.
And what about your interest in the digital technology side of the project and the big data?
I mean, I didn't know much about anything before I came here, much about any of that, but this is why, again, it's an amazing experience to work with this stuff. Help develop an AI, it's really cool stuff working with pottery.
The artificial intelligence behind this is going to be working on image recognition. It's quite important that it knows which parts of the photograph that it's seeing is part of the sherd as opposed to background. And if we were to have a background which is like my skin, that would be much more difficult. Whereas we can easily tell the machine, ignore anything green, and what you have left is the pot. So this is why we are wearing these neon green gloves.